Hello students, a very good evening. Welcome to Turito. In today's lecture, we are going to learn some applications of binomial theorem in permutations and combinations. So today's lecture is mainly focused on how to use the ideas of binomial theorem or multinomial theorem in today's lecture in permutations and combinations. So let's have a look at the basic ideas. So first I am going to take you through the process of selection to explain you the main idea of this concept. So we can also call this as multinomial theorem in PNC, or we can also call it as binomial theorem in PNC, or we can also call it as generating functions or generating polynomials in permutations and combinations. So there are actually three names to this concept. One is binomial theorem in PNC, multinomial theorem in PNC, generating polynomials in PNC. Okay. So how do we understand it? Let us start it from the process of selecting certain objects. Okay. Suppose let us say there are 5 objects. Okay, so let us say there are 5 objects and you are interested in selecting any 3. So in how many ways you do that? You do it in 5C3 ways. Okay. Now if you recall our calculation here, 5C3 is going to have 3 numbers, 5 into 4 into 3 divided by it is 3 factorial. What is the meaning of these numbers? As I keep saying, every number is having a meaning. So first number represents the first selection. So let us say there are 5 people here or 5 objects here. When we select the first object, we have 5 options. So we are making the choice here. Okay. So we have 5 options. First selection has 5 ways. Now when we are selecting the second object, we have 4 options. When we are selecting the third object, we have 3 options. These 5, 4 and 3 are the choice that we are making. And we are dividing with 3 factorial because order of selection is not important to us, but in 5 into 4 into 3 all orders are counted. So to balance that over counting, we divide with the 3 factorial, which is the orders among those 3, right. So here calculation is done with respect to us, with respect to the person who is doing the selection. Now let us say if you do this calculation with respect to the objects, then how will the story be? Every object is going to have 2 options only. Either it gets selected or it does not get selected. Now based on this idea, we are going to generate some polynomials to solve the question. Okay. So here this is actually a very simple task, simple idea, but we have to understand how to generate a function. So I have taken only simple question to explain you that. But remember that whatever we are doing today, everywhere we are going to give choice to the objects. Objects are making the choice. Okay. Now let us take 5 objects here. Okay. So I put some 5 smileys here. You can also take them as 5 people or 5 objects, it does not matter. Okay. So this is object 1, this is object 2, this is object 3, object 4, object 5. Okay. Now when we give the choice to the objects, every object has only 2 choice. Either it gets selected or it does not get selected. So we will be representing the selection with 1, no selection with 0. Okay. So selection means 1 and no selection means 0. These are our representations. And whatever the polynomial that I am going to generate, that polynomial will be having powers. Okay. So for the first object, x raised to 0 represents it not being selected, x raised to 1 means it is being selected. Okay. So what is the power representing here? Power is basically representing selection. Okay. And the coefficient will be representing. Coefficient will be representing number of ways. So that means what is the coefficient of x raised to 0 here? It is 1. So object can get not selected in one way, object also can get selected in one way. So both terms are having coefficients 1. Okay. Now power represents selection, coefficient represents number of ways of selection. So this is for the first object. Can we do it for the second object? Of course we can do it in the similar way. So for second object also function becomes 1 plus x. Similarly for third object, similarly for fourth object, similarly for fifth object. Okay. So now if you notice we are having 5 factors here. Now are we going to multiply them? So for that you have to check whether all of them are having choice or not. So first person's choice and second person's choice, or first object's choice and second object's choice, these two do not affect each other, they are independent events, so we multiply them. Okay. So whenever we have independent events, we can multiply the number of ways, we can also multiply the probabilities. Okay. So these are basically independent events. Now if you take the collection, you are going to get 1 plus x raised to 5. Okay. When we open this, what are we going to get? We will be getting 5c naught plus 5c1 into x plus 5c2 into x square plus 5c3 into x cube. So I will just write all of them because this is our first idea of discussion. Okay. So every term here is representing something. Every term is having a meaning. What is the meaning of first term? Look at the power of x here. Power of x is 0. So that means nothing is being selected. If the power of x is 1, what does it mean? It means one object is being selected. Power of x is 2, that means 2 objects are being selected. So power represents the selection and the coefficient represents number of ways. So 2 objects can be selected in 5c2 ways. Now if you want to still dig more and try to understand this at micro level, so let me take this term and explain you the process. Okay. X raised to 1 means whenever we multiply 4 factors. Okay. So from all 4 factors, some terms will come and they multiply, right. So but here there are 5 factors. From all 5, some terms will come and multiply, right. So let us say I take this x raised to 1 and I am going to represent it like this because it is coming from the 5 objects, right, and I have represented selection with 1, no selection with 0. So we can get it like this 0 0 0 1, okay, or we can also get it as 0 0 0 1 0. What does this represent? It represents fourth object is being selected, first 3 are not being selected, fifth is also not being selected. Okay. So this way I can write all possibilities here. Okay. So these are all my possibilities. So in these many ways I can select any one object. Okay. So how many ways are coming total? 5 ways are coming. So hence the 5c1 here. Okay. 5c1 represents 5. So here you understand that number of ways of selection is nothing but number of ways of collecting only one x from these 5 factors. Okay. So from these 5 factors, when you collect only one x, you will be getting 5c1. If you collect only 2 x's from all of them, you will be getting 5c2. Okay. So basically it is actually representing x raised to 1 here, which is also representing the selection. Okay. So this way you can understand that basically the coefficient here is representing total number of ways of selection, power is representing how many you are selecting. Okay. So this is what you have to understand here. It is very silly and simple example, but you have to form your basis of your entire methodology starting from this example. Okay. Come on, make a note of this. Okay. Now let's have a look at the same idea but using identical objects. What if the identical objects are taken? So if identical objects are taken, whether you are selecting one object or two objects or three objects, all are going to have only one way. So here what could be the function that we can write for all of them? For all of them we can write a function like this, starting from 1 x, x square, x cube, x raised to 4, x raised to 5, all these terms are going to come. And what does x square represent? Selection of two objects. And in how many ways we can do that? In only one way, because they are identical. So the coefficient must be 1. Similarly, for all terms, coefficients must be 1. So this way we can generate functions for identical objects. Okay. So this is for 5 identical objects. So here I have taken the case of 5 identical objects. Okay. So for 5 identical objects we will be writing the polynomial like this. Okay. So we only have to understand how to write the polynomial. Now there could also be a case where one object is being selected maximum 5 times. It is also possible. Okay. So if only one object, okay, could be selected maximum of 5 times. Suppose let us say if I take this case, then again the same logic could be applied, because one object can be selected in one way, it cannot get selected in one way, it can also get selected 2 times one way only, it can also get selected 3 times one way only, and 4 times also one way, 5 times also one way. So one object being selected maximum 5 times is same as 5 objects which are identical being selected at the same time. So these two are going to have the same functions because the logic is same. Okay. So this way we have understood how to write functions which are representing the selection. Now functions need not only represent selection, they can also represent some other ideas, but fundamental crux is the selection. Okay. So come on, make a note of this page also. Okay. Now that we have understood the idea of generating functions, let us conclude what we have learned here. Okay. So if our objects are identical, what happens? We have understood that selection process is a different process and every power will have the coefficient only 1, and also these ideas are also called as generating polynomials ideas. We have understood that. Okay. Now let us apply these ideas and solve some basic questions. So here there is one simple question. This question can be calculated very easily. So you know that our first question is the basic question to digest the concept. So here we want to select any 3 objects, select any 3 and from 5 different and 4 identical objects. So how do we do it? So one basic method that we have learned so far is making cases, right? So let us say I take the different objects here and I take the identical objects here. Now we want to select any 3. All 3 can come from different only. So this could be one way, this could be one case, okay, not one way. 2 can be different, 1 can be from the identical, 1 can be from the different, 2 can be from identical, or none can be from different and all 3 can be from identical. This way we can select any 3 of them. So how do we calculate the total number of ways? We have to calculate number of ways for each term, right? So what about this first case? In how many ways we can select 3 from 5 objects? In 5C3 ways. Into, in how many ways we can select 0 from the identical? In only one way. In how many ways we can select 2 from the different? In 5C 2 ways. In how many ways we can select 1 from identical? That is also one way. Similarly, we can select any one from the different in 5C 1 ways and identical in only one way. Similarly, for this also different in 5C naught ways and all 3 identical in one way. Now, when we add all of them, we are going to get the total number of ways of selecting any 3. Now, this is the method of making cases. So, here we have learned how to make cases, but let us try this using polynomial idea. Okay. So, here for selection of 5 different objects, how do we write the polynomial? It is going to be 1 plus x whole raised to 5, right. So, it is going to be 5c naught plus 5c1 into x plus 5c2 into x square plus 5c3 into x cube. So, let me just write all of them. Okay, so these are all terms. Now, what about the 4 identical ones? There are 4 identical here, right. So, for 4 identical ones, we are going to write the function using 1 plus x square idea. Okay. So, highest power here will be only 4. Now, what is the goal here? To select any 3. Now, selecting any 3, that means it has to go in the power. Power represents the selection. So, that means we are looking for the coefficient of x cube. So, when we take the coefficient of x cube, that will give us the total number of ways. Okay. So, writing function and realizing that we want the coefficient of x raised to 3, till here the P and C chapter is over. After that, question is going into the binomial theorem. Okay. So, basically we want to find the coefficient of x raised to 3. So, after we realize this, we have actually done it using permutation combination, but now the job is going into the algebra. So, this is a very silly explanation, silly example. So, collecting coefficient of x cube is simple here, but not always. Okay. So, for example, here if we want to collect x cube, so when I am taking 5c naught here, I have to take x cube from here. Okay. So, which means it will be 5c naught into x cube, 5c naught into x cube term, but because we are collecting only coefficients, it will be 1 here. Okay. Now, similarly, when I am taking 5c1 from here, so x is coming, so from here x square has to come. So, plus 5c1 into x square term, so it is 1. Similarly, when I am taking x square here, I have to take x from there. So, that means it will be plus 5c2 into 1. Now, similarly again, if I take x cube here, from here I have to take constant. So, that means it is 5c3 into 1. So, basically we have collected the coefficient of x cube here. So, which came out to be the total number of ways of selecting 3. So, if you check with the earlier case, they have matched exactly. Okay. So, these are 2 different ways of doing the question. Now, for this simple question, of course, this method is faster because you do not have to write too much, but we have to digest this idea. That is more important because the coming up next questions are FADU questions, very good questions, very tough questions. They can be solved using these ideas. Okay. Come on, make a note of this. This page also. Okay. Now, let us try to solve some problems based on this idea. So, let us say we have a problem here and here we want to select any 10 fruits. Okay, so you can also read the problem. And there are infinite identical apples, infinite identical mangoes and infinite oranges. Okay. So we have apples here, we have mangoes here, we have oranges here. Now how many apples are there? Infinity. Mangoes are also infinity and orange is also infinite. Now we want to select any 10 of them. So when we say any 10 of them, all of them could be apples, all of them could be mangoes, all of them could be oranges also. Now here all fruits of same kind are identical. So that means mangoes can be selected minimum 0 times till 10 times. All 10 could be mangoes only, or there could be no mangoes also. So all these are the possibilities. So in how many ways we can select any one mango? In one way, because all are identical. So even though they are infinite, number of selections of particular amount of or number of objects is always one way because they are identical. So for mangoes, if I write a function, how will that look like? It will look like 1 plus x square till how many maximum we can select? Only 10. So it will go only till x raised to 10. So this is the function I have written for the mangoes. What about apples? It is the same function. What about oranges? That is also the same function because both are having the same limitation, right? So that means we will be taking the power 3 because there will be 3 such polynomials. Okay. So we have written 3 polynomials for each of these objects. And now what is our goal? Our goal is to select any 10 fruits. That means we have to collect the coefficient of x raised to 10. So our focus is on calculating coefficient of x raised to 10. This will give us how many ways of selecting 10 objects or 10 fruits from here. Now till here the concept of permutation combination is over. Now the problem is going into the binomial theorem. So let us evaluate this using binomial theorem. So we have 1 plus x square till x raised to 10 whole raised to 3. Now the base is basically a GP. So we can use the idea of GP here. So 1 minus x raised to 11 by 1 minus x whole cube. Again we can write this as 1 minus x raised to 11 whole cube into 1 minus x raised to minus 3. Now 1 can be expanded using the normal binomial theorem, other can be expanded using the binomial theorem for negative integral index, right. So how do we do that? 3c naught minus 3c1 into x raised to 11, because this is first question I am writing all terms, okay. This is a minus b whole cube. Now the next one is 1 minus x whole raised to minus 3. How do we write this? You recall our ideas of binomial theorem, okay. So we can, if you recall this expansion 1 plus x whole raised to n, it's going to be 1 plus n by 1 factorial into x plus n into n minus 1 by 2 factorial into x square and so on till n terms, n plus 1 terms. So if you are writing 1 minus x whole raised to minus 3, what are the changes? Because this is an approximation form, remember that mod x must be less than 1, okay. And here these are the only changes. Put n to be minus 3 and put minus x in place of x, that's it. If you do this, you are going to get the required expansion, or you can remember the pattern that I am going to discuss, okay. So the pattern starts like this. It starts with 3c1, whatever is the power here, with that c1 will start, and this is x, and now 3 will go for plus 1 and this 1 also will go for plus 1, okay. So it becomes 4c2 x square. Now again 4 and 2 will go for plus 1, okay. So that means it becomes 5c2 x cube. This is the pattern. Once if you are clear about the pattern, you can directly use the pattern and solve the problems, okay. Now to proceed with the solving process, we need to know what happens to the general power, okay. So if I take x raised to r, what will be the coefficient? Okay, so here it is 5c3, okay. So for that we have to observe the pattern here. So when there is power 1, there is 1 here, when there is power 2, there is 2 here, when there is power 3, there is 3 here. So when there is power r, there will be CR here. Now again try to find the relation between 3 and 1. 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2. So that means here it should be r plus 2. So this is the pattern that we have observed, okay. Now let's go to and complete our goal, okay. So we are interested in coefficient of x raised to 10. So when I take 3c0 from here, that means it is the constant term here. From here I have to take x raised to 10, so that our net result is x raised to 10. So from here x raised to 10 will come when I put r equal to 10 here. So r equal to 10 will give me 12c10, okay. Now again, if I go to the next term, already the power is x raised to 11, we are interested in x raised to 10. So this has already exceeded the required power. So no matter what term you will take here, you will never get x raised to 10. So that means this is your answer, okay. So here the coefficient of x raised to 10 is 12c10, okay, because 3c0 is anyways 1. So I just wrote 12c10, or we can also write it as 12c2, right. We can also write it as 12c2, which also can be calculated as 12 into 11 by 2, which is 66, okay. So this way we can calculate the required number. So here if you understand, we have basically used polynomial to calculate this, okay. So come on, make a note of this. And this case, this page also. Okay. So this is the idea of writing the expansion for negative powers, okay. Now we can also solve it in a little different way. So let's say I take mangoes here, I take apples here. So which one did I take first? I take apples, okay. So let me take apples first. So let's say apples here, mangoes here and oranges here, okay. And I want to solve this by making cases. Let's say this is my instinct. You also might be getting this idea because earlier also we have solved the question using cases. Let me explain you what happens if you take cases, okay. So what happens when you take cases and how many cases will come? There can be many cases. We got the answer to be 66, so there should be 66 cases. Is there any standard method which will cover all these cases? What if in some situation you had to make cases, there is no direct method or polynomial, and let's say you have to make cases, what could be a better way of making cases without repeating them and without also missing them? How do you do that? For that I have one conventional technique. You can also develop your own conventional technique, but this is my conventional technique. This is the way I thought of writing the cases, and this is giving me better results. So what I'll do is, I'll give all variables, this is A, this is M, this is O, okay. I'll give all variables zeros first and I'll give all objects to the last one, okay. So total we want 10, okay. So total we want 10. I give zeros to apples and mangoes and I give 10 to oranges. That means all 10 are coming from oranges, okay. So here you don't have to worry about oranges or mangoes or apples. These are just 3 objects or 3 variables. A is one variable, M is one variable, O is one variable, and we want sum to be always equal to 10. Okay. So, how do we do that? So, this is one case. Now, there can be many sub cases also. For example, 0 10 0 is one sub case, 10 0 0 is another sub case. So, let us count sub cases separately. Okay. So, in this we are getting 3 sub cases. Now, this 3 is equivalent to arranging 2 zeros and 1 10 in a straight line, or arranging 2 identical objects and 1 different object in a straight line. That is in 3 ways, 3 factorial by 2 factorial. Okay. Now what is the next step? So, first I took a case, then I took all sub cases. Now, what I will do is I will take 1 unit from 10 and give it to its adjacent value. Okay. So, from here to here I will just give one value. Okay. So, then it will become 0 1 9. Now, how many sub cases will be possible? Because these 3 numbers are different, they can be arranged in 3 factorial ways. So, here we have 6 sub cases. Now, again do the same process, give one value to this. So, 0 2 8. Now, how many sub cases are possible? Again 6 sub cases are possible. Now, again follow the same pattern. Okay. So, 0 3 and 7, and again here there will be 6 cases. Now, again follow the same pattern, 0 4 6, now also there are 6 cases. Now, next 0 5 5, there will be how many cases? Only 3 cases here, because 2 are equal. Now, these 2 have become equal. Okay. So, now your question or your doubt might be this. So, we are giving 1 unit from the third and giving to second. Now, till where did we do we have to do this? You have to do it till these 2 become equal or just 1 unit away, equal or closest. Okay. So, here these 2 are equal. So, we close it here. Then we start from 1 1 1. Okay. So, we give 1s to both and give all the remaining to the next one, which is 8, and follow the same process. Okay. So, here there are 3 sub cases. Okay. And again 1 unit here. So, 1 2 7, there will be 6 cases, and again 1 3 6, again 6 cases, 1 4 5, again 6 cases. Okay. Now, 4 and 5 are closest. So, stop it right there and start with 2 2 2. Okay. So, 2 here, give all of them to the remaining. So, 6. How many cases are there here? There are only 3 cases. Now, what is the next step? Again follow the same. So, 2 3 5, how many cases? 6 cases. And next 2 4 4, how many cases? 3 cases. Now, close it here because these 2 have become closest. Now, start with 3 3. Now, the last number becomes 4 only. So, these are how many cases? 3 cases. That is it, we close it here because 3 and 4 are closest. Okay. Now, what about the other cases? They are already taken care in these sub cases. Okay. For example, if this is having 8, then that is already taken care here. Okay. So, if you follow this, you may have to go till only 10 by 3, because there are 3 variables here, A, M and O, and total sum has to be 10. So, you may have to go only till 10 by 3. With this you will get all cases. If there are 4 variables and total is 10, you may have to go only till 10 by 4 box. Okay. So, that way you can make all cases. Okay. So, now coming to this, what will be the total? Will the total match with 66? Let us check. So, how many 6s are here? There are 4 6s. So, I think we have more 6s than the IPL match here. Okay. So, here 1, 2, 3, 4, 5, 6, 7, 8 6s are there. Okay. So, 8 into 6 plus 1, 2, 3, 4, 5, 6 3s are there, plus 6 into 3. You want to calculate the sum. So, let us say I take 6 common, 8 plus 3 is 11, which is 66, it has matched. Okay. So, this way you can also make cases and solve the problem, but making cases is generally the very long method, but you need to have a system of making cases. What if in some question you have to make cases, then you need to have one system. So, here is your system which will help you not miss any cases and also not repeat any cases. Okay. So, I hope you understood the idea here. So, this way also we can solve the problem here, because here, wait a minute, I have only counted the number of cases, but I did not count number of ways. Number of ways are always 1. Why? Because objects are identical. In how many ways? You can select any one object from these A identical objects one way only. From mangoes also you can select any 3 in one way because all are identical. For this also there is only one way, all are identical. So, 1 into 1 is 1 into 1 into 1 is one way only. So, whatever are the number of cases will be the number of ways. Okay. So, that way you can justify your logic, and you can also understand this entire logic here with these making cases also. So, both are going to give you the same answer. Okay. So, I explained the same ideas using different problems, sorry. I have explained the same problem using different ideas. Okay. So, I hope you liked it. Come on, make a note of this. Okay. Now, let us go to the next problem. So, this problem is about how many non-negative integral solutions are there for this equation. So, non-negative means they have to be integers and also they have to be whole numbers. So, what are the possibilities of x? X can have least value 0, it can have 1, 2, 3 or maximum till 10 only. Similarly y, similarly z. So, x, y, z all 3 should belong to these numbers, and sum of all these 3 must be 10. What could be the answer? Answer is 66. Isn't it same as the earlier question? Of course, yes. So, the number of cases here that we are getting are actually the number of solutions. Okay. So, every case here is representing a solution, every sub case is representing a solution. So, there should be 66 ways, or in other words we can also start it right from here. So, let us say if A is the number of mangoes, and let us say if M is the number of, sorry, A is the number of apples, M is the number of mangoes, O is the number of oranges, then A plus M plus O must always be 10, right. So, this question and this question are exactly same. So, we can also solve this question using a different idea, but I am going to discuss that idea in the lecture of integral solutions. But here try to understand that we can write a polynomial for x, y and z and solve this. Okay. So, what could be the polynomial we could possibly write? We can write a polynomial like this. Okay. So, from p raised to 0 to p raised to 10 for x, for y also similar, for z also similar. So, whole cube, and we will be collecting the coefficient of p raised to 10. Okay. So, this way we can understand that this problem and the earlier problem are exactly same. So, number of non-negative integral solutions and number of selections could always be linked. Okay. So, I hope this is clear. Come on, make a note of this. Now, let us have a look at another problem. So, here 6 fair dice are rolled. What is the probability that sum of all outputs is 20? So, question is on probability, but the idea is from permutations, combinations, and the crux of that will be on polynomials. Okay. So, let us try to solve it. There are total 6 dice. Now, each dice is having 6 outputs which are possible, right. All outputs are equally likely because here it is said that it is a fair dice. Fair dice means all outputs are equally likely. Okay. So, number of ways of 2 coming is same as number of ways of 3 coming, all are having only one way. So, for first dice there are 6 outputs, for second dice there are 6 outputs, for last dice also there are 6 outputs. So, total there are 6 raised to 6 outputs. So, that means in the sample space we have total how many elements? 6 raised to 6 elements. Now, our goal is to calculate the favorable space, okay, and the probability is going to be equal to total number of elements in favorable space divided by total number of elements in sample space. So, sample space is anyways going to be 6 raised to 6. We only have to calculate the favorable space. How do we do it? We will write a polynomial for each dice. Okay. So, let us take dice 1. So, for dice 1, starting from 1 till 6, all are having equal number of ways and all are having only one way. So, I will generate a polynomial where my power is representing the output on the dice. Okay, power is representing the output on the dice. So, that means I can start with x raised to 1, x raised to 2, x raised to 3, x raised to 4, x raised to 5, x raised to 6. This is for the first dice. Now, again we can also do it for second dice, third dice and till sixth dice. Same polynomials will come because all are having the similar situation. So, raised to 6. Now, what is the goal? To get the coefficient of x raised to 20, because we want sum of all of them to be equal to 20. I hope this is clear, which also means somewhat like this. Okay, so, we have many pages here. Let us say there is a polynomial here, there is a polynomial here, there is a polynomial here and so on. There are total 6 polynomials. Okay. So, from this I am getting, let us say, x raised to a. From this let us say I am getting x raised to b. From this x raised to c, from this x raised to d and from this x raised to e and from this x raised to f. Let us say I am having certain factors like this, and here what is the goal? Goal is to check for this a plus b plus c plus d plus e plus f must be equal to 20. That is exactly what we are looking for here. Okay. We want sum of all outputs to be equal to 20, and where all these numbers a, b, c, d, e, f, all these numbers are belonging to this set. Okay. So, in a way this problem is also selection of numbers problem. Okay. So, all these numbers are belonging to these numbers only and sum of all of them should be equal to 20. This is exactly what we are dealing with. Okay. So, that is why we are calculating coefficient of x raised to 20, because we want sum of all powers to be 20, which means sum of all outputs of all 6 dice to be 20. Okay. So, we are basically going to get x raised to 20 from here. So, how do we do that? We can take x common first. So, we will write it as x raised to 6 into 1 plus x square. These are some simple simplifications till x raised to 5 whole raised to 6. We can also write this as x raised to 6 into 1 minus x raised to 6 by 1 minus x whole raised to 6. So, there are so many 6's here. Okay. And further x raised to 6 into 1 minus x raised to 6 whole raised to 6 into 1 minus x whole raised to minus 6. Okay. Now, I am going to expand this. Okay. But we have one x raised to 6 which is already outside, and here this is going to be a binomial theorem, normal binomial theorem. Okay. Now, I am stopping till x raised to 18, because after this the powers will exceed 20. In fact, this term is also not required, because there is already x raised to 6 here. We want total to be x raised to 20. So, if already x raised to 6 is there, from here onwards we will be requiring x raised to 14. Okay. So, now here I am going to expand this with this idea. So, it starts with 6c1 x, and every time 6 and 1 will be having one increment. Okay. So, 7c2 x square plus 8c3 x cube and so on. Okay. Now, further we want to just simplify this and collect coefficients, but we have to write the general term here. Okay. So, in this, if I am writing x raised to r, then here this 3, if you follow this pattern, so here we should be getting CR. Now, observe what is the difference: 6 and 1, 7 and 2, 8 and 3, difference is 5 units. So, this must be r plus 5. Okay. Now let me use it to calculate. So we want to collect the coefficients of x raised to 20, but there is already x raised to 6 outside. So from here onwards I need coefficient of x raised to 14. So coefficient of x raised to 20 is basically same as coefficient of x raised to 14 here. So let me collect all terms. So when I take 6c naught, that means when I take constant from here I will be requiring x raised to 14. So put r equal to 14. So how much do I get? I will get 19c14. Now go to the next term. This is 6c1. That means there is x raised to 6 here. I need x raised to 14. So x raised to 8 should be taken from here. So put r equal to 8. That means it will be 13c8. Now again the next term. So when I take 6c2 from here, so there is already x raised to 12 here. From here onwards I need x raised to 2 to make sure that I am getting x raised to 14. So I will be going for x square, so which is 7c2. And that's it, I will close it here, because I am interested in only x raised to 14 here and these powers are exceeding 14. So from now onwards I will not get any more terms. So this is our samples, this is our favorable space. So this you have to put, okay. This you have to put here to get the probability, okay. So I hope you understood the main idea here. So here in this dice problem also, I have used the idea of generating polynomials to solve the question, okay. Come on, make a note of this. Okay. Now let us have a look at, okay, you have to make this, make a note of this page also, okay. Now let us have a look at a different idea of the same problem, okay. When we are generating function, what was our polynomial? Our polynomial was representing power means the output of the dice, coefficient means the number of ways, right. We can also modify this because our goal is to get the probability, right. So I can also generate functions with probabilities, okay. So I will make sure that the coefficient is probability, power is the output of the dice. So what is the probability of getting output 1? It is 1 by 6. What is the probability of getting output 2? It is also 1 by 6. So we can write our polynomial like this: x raised to 1 by 6, x raised to 2 by 6, x raised to 3 by 6, x raised to 4 by 6, x raised to 5 by 6, x raised to 6 by 6. And there are 6 such dice. Now from here, if you take the coefficient of x raised to 20, this will be directly equal to the probability, okay. So whenever we are taking the coefficient, you can also make sure that coefficient is probability. This is one smart idea which is not there in books, okay. So it's your own choice how you are going to generate your function or polynomial. It's your choice, you can put it anyhow, okay. Most of the books are having only number of ways. You can also assign probabilities, you can also assign frequencies, you can do anything, okay. So it's all possible, okay. So this idea also you can use and solve it, it does not matter, okay. So now let's go to the next problem. Here question is about in how many ways 15 objects can be selected from 5 different objects if repeated selections are allowed. What is the meaning of repeated selections? We cannot anyway select 15 from 5, okay. Definitely 15 is a bigger number than 5. So we cannot select 15 from 5 unless every object is being repeatedly selected, okay. So this is possible. So how do we do that? To do this, what we do is we allow each object to be selected maximum of 15 times. So that means for the object 1, our function will start from 1 plus x until it will go till x raised to 15. If it is having only one selection, so it will start it will start with 1 and end at x only. But if it can be selected 2 times also, that has only one way. It can be selected 3 times also, which has only one way, and it can be selected 15 times also. Okay. Now similarly, there are 5 such objects. So for all of them, we will be taking 5 such functions. So raised to 5, and what do we have to do? We have to collect the coefficient of x raised to 15 from here. Okay. So coefficient of x raised to 15 is going to give you the answer here. Okay. Now after this step, the problem is going into binomial theorem, and we have solved already enough questions on these ideas. So I am leaving it to you. Okay. So my goal is to only explain how P and C is applied here, and after that how binomial is applied, that's your job. You can watch those lectures and try to do this, but solving them is simple. Okay. So here basically you will be getting answer of 15 plus 5 minus 1c 15. This will be your answer. Okay. So which is going to be 19c15. Okay. So you try to see if you are getting the same answer or not. Okay. So this way you can do it, you can do the calculation, it is going to be simple only. Okay. So now let's have a look at a different kind of question. Okay. So here we have to find the non-negative integral solutions, but of this equation. In this equation, if you observe, for x1 what are the possibilities? It can start from 0 and it can go till 10, right? So for x1 I can write a function like this, 1 plus p square till p raised to 10. Okay. Similarly, for the second one, now here hold on a minute, x2 can take any value, any non-negative integer, but the coefficient 2 is making sure that that value is being doubled. So its contribution is 2 times the number that you are going to take. So if you take, let us say, x raised to 1, its contribution is double, right? So we have to take square here. Okay, so that means, okay, so here why am I taking x here? I will take p. Okay. So whenever there is x in the question, I am taking p in the solution. If there is no x in the question, I will take x here. It does not matter which variable you take. So basically from here, let us say if I get p raised to x1, from here I will be getting p raised to 2x2. Okay. Right, x1, x2 is 1 here, and because we are squaring it, we are having 2 here. Okay. Now similarly, if we go further, we will be having p raised to 6 and so on. Okay. So here we will be having p raised to 8 and there will be p raised to 10 here. Similarly, for the third one, because the contribution is 3 times, the power has to increment as multiple of 3. Okay. So 1 plus p cube plus p raised to 6 plus p raised to 9. This way you have to write the function. Okay. So that means from here it is going to be p raised to 3x3. Okay. And you want sum of all powers to be equal to 10. Okay. So this way, if there is any alteration in the coefficient, we can change alteration in our functions. Okay. We can generate our own polynomial depending on the situation and solve that problem. Okay. So here we have to collect coefficient of p raised to 10, that will give you the answer. Okay. You can also make cases here and solve this easily. In fact, making cases here is faster than doing this. So I hope you can solve it on your own. But if at all you are going for the function, this is the idea of writing the function. Okay. Now let me take you to a different question. Okay. So here also I will just explain it and leave the workout to you. Okay. So here we have to select n letters, okay, combinations of n letters out of 3 n letters. So of which n are A's and n are B's and the rest are different. Okay. So that means there are n A here. Okay. So A's are how many? N, and B's are how many? These are also n, and remaining n are different. Okay. and we want to select any n of them. Total there are 3n, we want to select any n of them. So how do we do this question? We will be doing it by writing polynomial. Okay. So for this I will be writing a polynomial of 1 plus x square till x raised to n, because all these a are identical, all these are identical, so I will write the function for the identical, and all these are identical again, all b's are identical, so again the same function for the second also. Okay. So it will go till x raised to n. But what about the next one? This is going to be a different one. Okay. Because all are different, we will be writing 1 plus x raised to n for all of them. Okay. So now what is our goal? Our goal is to collect the coefficients of x raised to n from this expansion. So we will be writing two ideas here. So one is there is 1 plus x whole raised to n, and here we are having 1 minus x raised to n plus 1 by 1 minus x whole raised to 2 here. So we will be expanding this using negative binomial theorem, and we will be collecting the coefficients of x raised to n. Okay. So this way we can proceed with the problem solving. Okay. So our answer is going to be coefficient of x raised to n. So here the workout could be little longer, but you will still get the answer. Okay. So now what is the crux and conclusion of today's lecture? Whenever there is a process of selection, or whenever there is a different kind of question also, it could be based on the non-negative integral solutions, it could be based on the ideas of dice, it could be any such question, but we can always take help of writing polynomial, collecting coefficients, where the power is always representing the output or the solution, the values or the selection, and the coefficient is representing the number of ways. Okay. So this way we can solve the problems, and here till you realize that you need a certain coefficient, permutation combinations is over. After that algebra will start. You have to learn both methods and both ideas. Okay. So with this we will close today's lecture. I hope you enjoyed the discussion and also you enjoyed the ideas. We will meet again in the next lecture with some more interesting ideas. Until then, have a great learning day. Learning shall never stop.